So this is the first example that I will give you about parabola. Now, this is another general equations of general form of the quadratic relation, and we can see here that the a is 4 and the b is 0 if we refer to the ax squared plus by squared plus cx plus dy plus e equals 0. So this one is a parabola that either it's facing upward or downward, since this is also a quadratic function. So before we sketch it, it's wise for us to convert it into the general form of your parabola. So here it is by simple addition and subtraction, both sides. I can change it into a general form of parabola, as you can see here. Now we can see that it is y equals ax squared plus bx plus c. So it's a parabola facing upward. Why? Because the a is positive, which is 4. So let's start to sketch the parabola. To sketch the parabola, at least first, we have to know the easiest one, the y-intercept. So the y-intercept, just substitute x equals 0 into the equations of your general form, and then you find that the y-intercept is 0, negative 12. And then the vertex coordinate. Okay, let's use h, k. H is the x coordinate of your vertex and k is the y coordinate. So we have two methods. So the first one is by formula, which is the h equals minus b over 2a. So the b, you can see from the general form, is 8 and the a is 4. So just substitute all of it, and after we multiply and divide, it's negative 1. So the h will be negative 1 by using formula. The next one, to find k, actually we have two options. First, since we have already had the h, so to find the k, since k is the y coordinate of your vertex, just substitute h into your x. So this is the way of the first option. So I substitute the negative 1 into all the x into the general form, and then I will find that the value of your k will be negative 16. Okay, I hope it's clear. Or just use this formula, which is minus the discriminant over 4a. So the discriminant is b squared minus 4ac. So here it is. This is our calculation after we substitute all the components there. And then you can find that the result will still the same. Of course, it has to be consistently the same. So the k is negative 16, and yeah, we have the vertex is negative 1, negative 16. Now the second method will be by converting the equation into vertex form. As you can see, for vertex form for this kind of general form, you have to memorize it. It is y minus k equals a times x minus h squared. So let's convert this blue highlight general form into the vertex form. So the first thing that you have to do, first I write down the original, okay, and then I will add both members by 12. Why? Because I need to make the k here. Okay, so we just move, not moving actually, yeah, but the objective is moving negative 12 into the left member just by adding 12 both sides, and then we exclude the coefficient of x squared. It means if the x squared has a coefficient, for this example 4, we have to exclude 4 from these two terms. Okay, so this is the result. I divide both by 4, and then the next step is I complete the square inside the parentheses. So yes, this one I will add with something that was not there before, which is 1, to make it a perfect complete square. Why? Because the objective is to make this form. Okay, so since I add something on the right member, I need to add the same value on the left. Since there is a coefficient 4 here as your multiplier, you need to multiply 1 by 4. So you get your 4 on the left member. And then you just need to sum the left members to simplify it. So y plus 16. And this one you just factor it. Factor the right member, so you have x plus 1 square. Now we can compare head to head that we have already reached the vertex form. So after we reach that, we can extract directly that the k will be negative 16, the h will be negative 1, and that's all. Yeah. So it's the same with finding the vertex by formula. Of course, it's supposed to be the same. The conclusion is our vertex is negative 1, negative 16. So after y-intercept and vertex, the next one will be the x-intercepts. So for the x-intercepts, we need to check first the discriminant, since I want to know whether we have 2 x-intercepts, 1 x-intercept, or none. So let's calculate the discriminants, and we know that it's 256, which is, this is a positive, and it is a perfect square. Since it is positive and a perfect square, it means that we have 2 values of x-intercepts and they are rational numbers. It means you can use 2 methods actually. The first one by factoring. Okay, so from the original general form here, since we have to find the x-intercept, it means the value of y will be 0. And then you need to factor the right member. So let's do that. By factoring, we have that 0, which is your y, equals this, and I factor it completely. I have this. So next you have to find your zeros, which is 1 and negative 3. So yeah, by factoring it's quite fast. You can find the coordinates of your x-intercepts. So the second method will be by quadratic formula. So this is the more common and more global, so any cases can be, you can find your x-intercept, your x coordinates by using quadratic formula. So let's see and compare whether we will have the same result, and by referring to the formula and then substitute all the components, we can see that x1 will be 1 and x2 will be negative 3, and it's completely the same. So we have already had all things that necessary for us to sketch the parabola. We have at least the vertex, the x-intercept, and the y-intercept, which is 1, 0 and negative 3, 0. The last one will be, the graph. So let's check whether we have, when I plot it on the GeoGebra, actually, yes, we can compare that the result of our calculation and the graph is consistent. While the y-intercept is 0, negative 12, which is here. Okay, it is true, only one y-intercept, of course. The vertex is negative 1, negative 16, which is here. And the x-intercept will be 1, 0 and negative 3, 0, which is correct. So yes, for this kind of quadratic formula facing upward and facing downward, we have completed the explanations. Now next, the example of parabola which is facing right or left. Now here is the second example, and we have this kind of equations, and you can see that the x squared is not there. It means the a equals 0. So for this kind of case, since we have only y squared, x, y, and only numbers, so we have a parabola which either facing left or right. Okay, so let's first convert into the general form of a parabola. And we have this kind of form. So x equals ay squared plus by plus c, since we don't have x squared. So since this is the a, which is less than 0, it means we know that this parabola will face left. Okay, this is a parabola which facing left. So now, this is the first clue of our graph, since we need to sketch it. So what is the other things we need to find to sketch the parabola? Of course, the combinations of the x-intercepts, y-intercepts, and the vertex. So for this kind of parabola, the easiest one that we can find is the x-intercept. Why? Because when we put the y equals 0 into the equation, we can directly find what is the x. The value of x when y equals 0 will be the definitions of your x-intercept. So first let's find the x-intercept, which is negative 3, 0. And then next, let's find the vertex, which is, let's use h, k as your standard coordinate of your vertex. And then we have two methods, again, just like example number 1. The first method is by formula, but remember that for the formula for this kind of parabola, the k will be equal to negative b over 2a, not the h. Okay, so you have to be careful with that. So since the k equals this, so you just substitute all the components of a, b, c from the general form, and then you find that it is equals 3. And next, to find the age, so you have two options. Either you just substitute the k, which is the y coordinate of your vertex, to the general form to find the x coordinate of your vertex, which is the age. So by substituting 3 into this general form, I can find the age, which is 15. Or you can use, of course, the formula, which is h equals negative d over 4a, and then you just substitute all the components here, and then eventually you will find the same result, of course, which is 15. That is how you find the vertex h, k by formula. So next, how about by converting into the equation in vertex form? So the vertex form for this kind of equation, x equals, will be different with the example 1, which is it begins with x. So be careful also from the for this vertex form, which is different with the previous example. So the original, since we know that the original equation is this, how to make it into this form is first by adding both sides by 3. Adding both members by 3. Okay? And then the next step is you exclude the coefficient of y squared. Whenever the y squared has coefficient, exclude it. Okay? Exclude it by divide both terms on the right member by negative 2. So this one, it becomes this, and 12y, when you divide by negative 2, it becomes negative 6y. Be careful with the sign. Next, just complete the square inside the parentheses. Since this, there was no 9 before, but since I need to complete the square, I add 9 inside the parentheses. Since I add something on the right member, it means I need to add the same value on the left member, but keep in mind that there is a coefficient here. So when I add 9 inside the parentheses, since I need to multiply it first by negative 2, so I will have the equal value on the left member, which is negative 18. And then just simplify the left member and factor the right member, and you have this. So of course you can compare with the vertex form. We have already had the vertex form, and since this will be the age, so the age will be 5, and here's the k, so the k will be equal to 3. So in the end, h equals 15, k equals 3, which is the same with the formula's result. K equals 3, h equals 15. Okay, so again, you can use both methods. You can choose one. And then let's find the y-intercepts, the last one. The y-intercepts, of course, I always be interested to find first what is the situation of y-intercept that we face, whether it is two y-intercepts, y or 1 or 0 or none. There's no y-intercept. By looking for or finding the discriminant. Let's check the discriminant. Of course, you can see that the original equation is this. So the discriminant will be b squared minus 4ac. Just substitute the components from the general form and you find it is 120. Since this is still negative discriminant, but not a perfect square, it means we have two y-intercepts, but the value of that y-intercept will be radicals, irrational. It means since it is radicals, we can only have one option of method, which is quadratic formula. So before we go to the quadratic formula, since we are looking for y-intercepts, so we have to substitute the x equals 0 to find the y. We are looking y-intercepts into the general form. So since the general form is this, so I will substitute x equals 0 and I have this statement. And then I need to find the value of y by using quadratic formula, since I cannot factor it, since it is not a perfect square, the discriminant. So we have this quadratic formula, just substitute. So we have y1. I separate y1 and y2, so it can be clear. So this is the plus, and this is the minus, plus minus. So I have two different value. So since it is radicals, I leave it in radicals in the simplest form, and then this is the statement. I hope we're clear. So after I just substitute, I simplified, substitute, simplified, and then this is the final answer, which is in coordinate, of course, the y-intercept. The coordinate will be 0, comma, this. And y2, y-intercept, the second y-intercept will be 0, comma, this. If I need to plot it, of course, I cannot leave it in radicals. I need to find the approximations of my of the value. So after I find it via calculators, so yeah, this is the coordinate in decimals approximation value of the radicals. So it will be around 0.2614 and 0.5.7386. So now let's check these all things that we have found, which is vertex, x-intercept, and y-intercept via graph. So again, this is the conclusion: the x-intercept, the vertex, and the y-intercept that we have calculated before. And when we check by graphing, this one I use GAWVI. Yes, we have a confirmation that the x-intercept is negative 3,0. The vertex here is 15,3, and the y-intercept is, yeah, it's around there. Of course, 0.2614 and 0.5.7386. So that is how you sketch a parabola who face left. So if the parabola faces right will be the same.